Hi, this is my final project presentation for CSCIE E90 course. My project is about centralized logging. The goal of the project is to create a centralized logging platform using Amazon AWS services that can be used to ingest logs, process them, and then store persistently in Elasticsearch and S3. This is a high-level design of the project. The entry point of the logs is Amazon Kinesis data streams, and once the data is in Amazon Kinesis data streams, it is picked up by Kinesis firehose. There are two instances of Amazon Kinesis firehose running, one to send the data to Elasticsearch, and the other is used to send the data to S3. Both of them run in parallel and consume the data from the same Kinesis streams. Once the data is persisted in Elasticsearch and S3, the data in Elasticsearch can be searched upon using Kibana. We can also build dashboards and visualizations using Kibana. The data sitting in S3 is for long-term storage, and that data can be accessed through Amazon Athena using ANSI SQL queries. And we can also build dashboards using Amazon QuickSight. The real-time use case here with the data in Elasticsearch is for IT application developers and operational specialists who who are troubleshooting application issues and performance issues. This can also be used by cybersecurity analysts to get alerted on security breaches. The data here is really time sensitive, and we need to keep the data only for a few days or weeks at a time. However, the data in S3 is for historical and long-term archival purposes. This is typically used by auditor compliance folks to get to investigate issues and legal concerns. And the other type of use case here could be that business folks want to get insights of changes in user behavior over a long period of time. So these are two different use cases, and the platform is will be able to address both the use cases. Like I said, we use multiple AWS services, but we also use a Kinesis data generator to generate a large amount of data, log events. Typically, thousands of log events per second. So all these log events are put into Kinesis streams. We use a GitHub project called Kinesis Data Generator. This is a AWS Labs GitHub project, and they provide a CloudFormation template that we can use to provision the services that are needed to use it. The main entry point for the log events is Kinesis data streams. It is a very scalable and durable real-time data streaming service from Amazon. We use Kinesis firehose. Kinesis firehose is basically used to grab the data in Kinesis streams and ship it to a specific location like Elasticsearch or S3. In our case, we want to use two instances of firehose, one to send the data to Elasticsearch and other to send the data to S3. We use Elasticsearch and Kibana. Elasticsearch is a very fast, real-time performant distributed indexing and search service. It is fully managed by Amazon, and we don't have to worry about patching it, maintaining it, or upgrade it. Once the data is in Elasticsearch, it can be queried using Kibana and build dashboards and visualizations in Kibana. The data sitting in S3 is in JSON format, and the data can be accessed in Athena using ANSI SQL queries. We can also build dashboards and visualizations using QuickSight. I'll be showing you a demo shortly, and all the services that are discussed in this deck so far will be provisioned automatically using something called Terraform. Terraform is used to provision infrastructure using code instead of going and manually clicking in the management console. With that, it's time for demo. I would like to pause the video here. All right, I opened my terminal, and I'm going to go to the project folder. So these are all my Terraform scripts. There's also a CloudFormation template that we downloaded for the Kinesis data generator that will be used to generate logs. So everything is provisioned automatically by Terraform. I'll show you a quick example Terraform. So this is my S3 Terraform script. This is where I will be creating, this script will create basically two buckets. One for storing all the log events that are generated in S3 bucket. And the other bucket will be used for if there are errors sending the data to Elasticsearch. This is the backup folder where the events gets created. It's it's all coded. We don't have to go into the management console and manually click to create the services. This is really useful, and as you can see, as you will see, most of my services that I use, will use encryption enabled for security purposes. All right, so the way to get this going is we use a command. We have to configure the credentials first. So AWS configure. I already configured it, so the credentials are already there. And once the AWS credentials have been created, we use Terraform init to download all the plugins and things that are required by Terraform to execute the scripts. In my case, I already downloaded, so everything is ready to go. The next step is to do Terraform apply. At this step, Terraform basically looks at all your scripts in that folder. It plans out the execution. It figures out the dependencies on which resource is dependent on which resource and makes an execution plan. Basically, it knows exactly what needs to be built out. In our case, this is since we don't have anything built out yet, it will be creating all the services and all the security groups, IAM roles, everything that is needed. And we have a total of 13 resources as part of the script, and we don't have anything to change or destroy. So the prompt is asking me if I confirm that I want to create all those 13 resources. I will type in yes, and that should kick off the Terraform script. I'm going to stick around for a few more seconds and then pause the video. Most of the services are provisioned very fast, but the Elasticsearch domain, it's built on servers by Amazon, and it takes about 15 minutes to provision that. So I'm going to pause while it's getting provisioned. But as you see, most of the services are getting provisioned as we talk. With that, I'm going to pause the video and come back once the Terraform is done executing. All right, I'm back. So the Terraform took about 12 minutes to provision everything. Elasticsearch domain definitely took the longest. Everything else was provisioned within a few seconds. With that, and as you can see, all the Terraform script was successfully complete. All the 13 resources were added. At the end of the script, it provides the output. Basically the script that I wrote, I put out some things that are useful for later in the demo. So one of them would be the Kibana endpoint URL here. We'll also be using a web interface to generate the logs. It's called the Kinesis data generator, and the URL for that is over here. So we'll copy both the URLs first. So Kinesis data generator is a AWS Labs web application that is used to generate logs or any type of data really, and send it to the Kinesis streams or Kinesis files. So let me start by sending data first, and then I'll show you all the services that we provisioned. So, all right, copied the link and opening up in the web page. So this is the Kinesis data generator web interface hosted by AWS Labs. As part of the Terraform scripts, we created a Cognito user pool and a user. The password, the username and password is CSCIE 90 is the username. Password is password with a 0 instead of the letter O. Right, once you sign in, once you sign in, you have to pick the region. The Kinesis data generator only works in US West 2, the Oregon region. So everything that we created as part of the Terraform is actually provisioned in US West 2. So the Terraform scripts only work for that region. It won't work for US East. So I'll pick the US West 2 region, and I should see the Kinesis stream that we created, US West 2. And yeah, this is the CSCIE 90 mainstream is the Kinesis stream that we want to put the log data to. So we pick that, and then we can choose at what rate we want to send the logs. We'll do about 1,000 logs per log events per second, and we have to pick the template for the log format that we want to use. So that log format is already pasted here. We will use that, and we can start by sending data. So the data generator is generating log events and sending it to our main Kinesis stream. With that, I will go to the AWS management console and show you quickly the services that are provisioned. We'll start at the main console. So this is a login page for the console, and we'll go to the Elasticsearch service. And this is a cluster that was provisioned. It's all green. If you click on the server, you'll see that it is a one availability zone, one node. But by simply making the changes in Terraform, we could scale it into multiple nodes and distribute over multiple availability zones. And also to note is the encryption has been enabled both at rest and in transit, and we use KMS for encryption. We'll next jump into Kinesis. Kinesis has multiple services. We use the Kinesis data streams and Kinesis data firehose. So this is the stream, the Kinesis data stream you see here is the main stream where the log events are enter the environment. So we created 5 shards. Shard is basically the unit of throughput. If you want to send more log data, you could increase the number of shards, again by simply making a change in the Terraform and reapplying the changes. This encryption is enabled, and the data in the Kinesis stream is written for 24 hours. This is a serverless, fully managed service by Amazon. We don't have to worry about patching or upgrading or anything like that. Amazon manages everything for us. And once the data is in Kinesis stream, Firehose picks up the data from stream and sends it to destination. We use 2 Firehoses instances, one for sending the data to Elasticsearch and the other to send the data to S3. So both of them are provisioned and active. As you can see, this instance is sending the data to Elasticsearch. It batches up, buffers up log data and sends it out to Elasticsearch when one of these thresholds is met. We'll quickly jump into the other stream. This is the S3 stream. This is used to send the data to S3 bucket, and all the bucket configuration is over here. And again, this also buffers up and sends it to S3 bucket in a compressed gzip format. All right, one other thing to note is in the Elasticsearch Firehose, if the data, if the Firehose is not able to send the data to Elasticsearch because Elasticsearch is down or something like that, it uses a backup bucket that was also provisioned as part of the Terraform, and it keeps data in that bucket until the Elasticsearch service comes back up. All right, we'll also see the S3 buckets that are created. So 2 buckets were created for this project. This is the main bucket that holds all the data, log data. We don't see any data yet, but it should arrive shortly because it buffers up. And then this is Elasticsearch backup bucket. If Elasticsearch is down, the data would come here. All right. Now let's go back to Kinesis data generator. So it's sending a lot of data right now. Let's see if we can log into Kibana and see any of the data. So I go back to the Terraform script, copy the Kibana URL. There's the Kibana URL, and I will open up in the browser. So in the Kibana URL, the first thing to do is once it's up, go to the management and index patterns and see if there is data. So right now there is no data coming in, so we have to wait for a few minutes. I will pause the video here and come back when it's ready. All right, so I was able to see the data coming in Kibana. So when you once you log into Kibana and click on the index patterns, if you see something show up here in the create index pattern, that means the logs are there. Already persisted in Elasticsearch. So the first thing we do is create the index pattern. This will be used to search and for and building dashboards. So we create next step and click on the create index pattern. So it is creating the pattern. Once the pattern is created, these are all the fields, and it identifies the type of the field. So the index has been created, index pattern has been created. We can go into the discover tab here and start looking at the data. So this is the amount of logs. This is the number of logs we have received so far. If you go back to the Kinesis data generator, so this is how many records were generated. So Elasticsearch takes time to index the data, but once the data is indexed, it is real time when it comes to search. The search is really performant in that regard. All right, so going back to Kibana, we can refresh it and see that the number of documents keep going up. Right, one thing we can do is for searching, we can filter out the data. So if you want to get only log events for country code TC, you could do that here. So this would give you only TC country code logs. So the dashboards can be built in Kibana as well. But the first step is to create visualizations. What we can do is we can create some metrics here using the index pattern, and we already have the metric count here. So we'll call it the total log events. Total log events, and save this metric. Save this as total log events. We'll create some more visualizations. Go back to visualization, click on the create new, another metric, logs, metric here, add a filter where we want to see only the number of events that have 404 error code. So is 404. All right. So this is events with 404 error code. Save the visualization. Error code event count, and then go back here, create one more, something more like a chart or a pie graph. So logs, we can create a pie chart, donut, not donut, show labels, data, size count, split size slices, use terms, and then select the field, which would be the response codes. So we want to see how many response code events per response code. So let's say 15. So 200 was definitely the most response code. The log events were the most response code. 66.58% of the log events were of error code of response code 200. The rest were evenly distributed. So once the visualizations are created, you need to save this as well. Pie chart. All right. Once the visualizations have been created, we can go back to the dashboards, and here we can create a dashboard, and we can add our visualizations. So all three have been added, and we can rearrange them. We can say total log events. We can say we can make this smaller, move this sideways. All right, the dashboard is ready, to be saved. I will call it the CSCIE 90 dashboard. Confirm save, and so you can keep refreshing it, and you should see log events come in. Now we're going to go into the other aspect of the other use case where the log data is stored in S3 and needs to be accessed from Athena and QuickSight. So we go back into the Amazon console, go to the S3 bucket. So go to the bucket and we can see the log data here. So all the all the log events are persisted in, you know, buffered up objects that are compressed in gzip format. So we'll access this data that is sitting in S3 using Athena. So Athena is again a AWS service. And the first thing we do is we actually create a database. It looks like we already did that, but I'm going to delete that and recreate that. Right. So it's all empty now. So I'll create the database first, and then I will create a table, external table. Basically, it says all the fields that are in the log event and the format the data is in and the location of the data. So this is like a Hive table where the data is not really moved from S3 into this table. This is just the table is overlaid on top of S3 when it comes to querying time. So the data is just sitting in the Apache Athena catalog. So query, create the table, and then we have partitions by year. But since we only have log events for 2019, that's the only thing we do. But since the data is partitioned, we have to recognize the partitions. We have to make sure Athena recognizes the partitions. So run the repair table query. And then we can start looking at the count of we can do a small SQL command to get the count of log events, that are sitting in S3. So this is real time, because we don't have much data sitting there. But usually, if you have like terabytes or petabytes of data and it's partitioned well, it could take like a few seconds or a few minutes to get back the results of the query. But it's usually pretty good, for the amount of data that is, sitting in S3. So we have been able to prove that we can use SQL queries to access the data sitting in S3. We'll do one more query here. We can get select star from CSCIE 90 Apache logs, limit to maybe 100. All right, so we're getting the first 100 log events from the table. So it should be pretty quick. All right, there is some problem with the query. It's not able to recognize the limit. So anyway, you can execute SQL queries, and I'll stop at that, and I will jump into QuickSight. QuickSight is again another AWS service that can be used to visualize data from different data sources. QuickSight is a subscription-based Amazon service. So if this is the first time you're using QuickSight, you will need to sign up for the subscription. All right, I'm deleting the old dashboards that I built. So the first thing you do is you create a new analysis, new data set. We choose Athena as our data source, as our data set. We give it a name, CSCIE 90 demo logs. Create the data source, and then it asks us to pick up the database that we created. This is the database we created in the earlier step, and this is the table that we created in Athena. We select that. It asks us if we want to import the data or query the data in real time. So we want to query the data, not bring the data into QuickSight. So we'll check this off and start building the visualizations. So I'll stop the data generator. We have already sent like 130,000 log events. So I'll stop here and start creating the dashboard in QuickSight. Right. So the first thing we do is we'll create a metric. We'll create a calculated field first using count and log ID. We call it count of events. Create. All right, metric using this. All right, and we'll use a pie chart. Oops, metric count of events, and add another visualization. We'll use pie chart here and use response code. All right, it's all built. Let's see if we can build another. Oops. All right, so the dashboard is created. We have two visuals in it. One is the count of events, and the other is the response code pie chart. Now we need to share this and publish the dashboard. We'll call it the CSCIE quick site demo. We publish the dashboard. We don't need to share it at this point. So the data is, collected from S3 and queried upon using Athena in real time to display the dashboard. We'll jump back here. We'll refresh this. As you can see, both of these match. So there were 134,000 events generated, same as in QuickSight. So this proves that the log pipeline that we built using Kinesis streams and Kinesis firehose, it transfers the data in a reliable fashion from the data sources and persists into Elasticsearch and S3 without losing any log events and also without duplicating any log events, which are both very critical when it comes to logging platform. With that, the demo is complete. We can start tearing down the infrastructure that we built using the Terraform script. That is done by using Terraform destroy, and it will ask, plan out the execution and ask me whether I want to confirm to delete. With that, I'll pause the demo.